Okay, this is an example of a very long system. This is a medical endoscope, which is used to look inside the body. And this typically consists of a kind of an objective part that makes an image of what it sees inside the body. And then that image has to be relayed to outside, which is normally a very long distance. And for that, a number of relay stages are used to re-image and re-image and re-image until it's out of the body. And here, one can look at it with an eyepiece or with an eyepiece and a camera. Oh. It's too late. Let's go back to here. You see, this is the object, and it starts with a negative group here, which makes it a very wide angle objective. And then we have a doublet, a triplet, and a doublet. And finally, we have our image here, which is an intermediate image. And basically, we are finished now, but we have to transport that image to outside. Here, at this position, we do have the aperture stop, because all the principal rays, they pass through the optical axis. Let's go to the relay part. You see here was an image by the objective, and this is imaged with a 1:1 ratio, so -1 magnification to another intermediate image here. This imaging is done by this pair of lenses, this pair of objective lenses. And you can see that somewhere in this area the principal rays again pass through the optical axis. So it looks as if we have an image of a stop here. These two lenses here, they are very near to the object in the image, and they are more or less field lenses. And the significance of those lenses we will see just now. Okay, this is repeated from here to here, and again here we see the principal rays passing through the optical axis. So here we have again an image of the stop, the aperture stop. And finally we have the last relay stage from here to here, and again here we have an image of the aperture stop. And then here is an intermediate image again, and on this position one can put something to measure, for instance a reticle, but most important here is to put the field stop, to have a nice sharply defined region where one wants to look. And this image is observed through an eyepiece, and this will image it to somewhere here, far away, so you can easily observe it. And again here we see that the principal rays pass through the optical axis, so here we have again an image of the aperture stop, and obviously this is the exit pupil. So if you go all the way back, and now we go to a slightly different situation. As an exercise, we just put our object at the position where the aperture stop was located, just in front of the doublet. So we consider the aperture stop as an object, and we see where it is imaged. And you see, indeed, somewhere in this area we have an image of the aperture stop. Somewhere at the location of the two objective lenses. In the second relay stage, the same happens. And here again. And now we see the significance of the field lenses. Because now the field lenses, they act as imaging lenses for the aperture stops. Here we have an image of the aperture stop. And this image of the aperture stop is re-imaged by another image of the aperture stop. And that is done by the field lenses. What does it mean physically? That all the light that is present here will be forced into this aperture again. So the field lenses serve as to maintain the amount of light in the system. Otherwise, a lot of light would be lost. Because imaging of the one aperture stop on the other aperture stop means the light that I have here must also be available here. And finally, we see that the aperture stop is imaged here on the exit pupil, right? Which is obvious.